Hello, everyone. My name is Veronica McGowan, and I'm a structures operations engineer here at Virgin Galactic. And today I will be giving you guys a virtual tour of our operations facility, as well as our manufacturing facility, and an overview of the vehicles that we fly here at Virgin Galactic. Now, I can't show you anything live on the hangar right now due to ITAR reasons, which for those unfamiliar, ITAR stands for International Traffic and Arms Regulation. But we have a really cool slide deck here and a lot of videos to hopefully give you the feel of what it's like to actually see the facility in person, as well as the vehicles flying in person. So with that, let's go ahead and get started. I'm going to start with our Gateway to Space building. This is the main operational hub here at Virgin Galactic. It's located at Spaceport America. And we call this building the Gateway to Space because it is quite literally a gateway to space. This is the last building that human beings will step foot in before becoming astronauts. So this is where we have all of our operational facilities. This is where our vehicles in operation and the later stages of flight test are housed. It's also where I'm sitting right now. So I am located in this building, and we're going to give you a great overview of what it's like to be here in person. So just looking at this aerial view for starters, the whole design of this building was really on the exterior to be able to blend in with the environment and really ground you to Earth. So from the back perspective, as you're coming in, it looks like it kind of blends in with the mountains. It's really pretty. And then you go to the east side here where it's showing all of the windows, and it really reflects the mountains in the background. So just beautiful scenery all around us. And it's really meant to, again, just blend in with the Earth, be one with the Earth. Now we have 3 levels to the building. The ground floor we call Gaia, and this is meant to once again ground you to Earth. So you see a lot of the earthy tones, and you can really bring it in with the color and design. We've got a lot of plant life there as well. And this is supposed to be a hub or a social hub between employees, also future astronauts and their families. So we've got a barista bar right in the middle for folks to gather around and talk together. Also several different places to lounge and to eat. And you'll see in the back right corner of the photo there, we have a kitchen on site as well. So Spaceport America is out in the desert, and we're a little far from restaurants. So we actually have a kitchen in-house where folks can make food and eat together as a community. So again, this is just grounding you with the Earth and a social atmosphere for folks to hang out and mingle and get to know each other. Next, we move up to the 2nd floor, and this floor is called Cirrus. And this is meant to be up in the clouds. So you can tell the colors are a lot lighter from our 1st floor on Gaia there. And it's a lot of white tones and things like that, and very appropriately up in the clouds. This is where our pilots sit, along with the medical teams and the astronaut trainers. This is where they all sit on a day-to-day basis for operations. This is also where we have our mission control center here at the Gateway to Space. Now we actually have 2 mission control centers, one at Gateway to Space called Horizon. And then we also have a mission control center called Oculus at our Mojave facility that we'll talk a little bit more about later in the presentation today. So we also have a 3rd floor here at the Gateway to Space, which you can probably guess the theme of. If we go from Earth on the Gaia floor to up in the clouds, Cirrus is the 2nd floor. You can probably take a pretty wild guess as to what the 3rd floor theme will be like. Now, this hasn't been revealed yet, so still a secret. Keep your eye on the news in the months to come. We're going to be revealing more about this floor. But this floor is where the future astronauts will be spending most of their time when they come here out to the Gateway to Space for training purposes. So now that we talked about the operational facility, let's talk about our vehicles that we house here, starting with our mothership, Eve. So we do have a 2-stage to launch system, meaning we have 2 vehicles, and the very first one, our mothership Eve, is the white dual fuselage aircraft you see in the image. And Spaceship Unity has just been released in this photo here hanging underneath it. But let's start out talking about Eve first, our very first stage in our 2-stage launch system. So Eve is a dual fuselage aircraft, and you can see, the fuselage is on the right and left there, and that center pylon is meant to carry our spaceship. And Eve is pretty incredible when it comes to performance. She has 4 Pratt & Whitney Canada engines, and we're meant to, tow a large spaceship all the way up to around 50,000 feet. So you can imagine the performance of Eve flying by herself is pretty incredible. Watching her take off, she can almost go vertical. It's fantastic. So really impressive aircraft in her own right, not to mention, the first stage of a space flight system. So you can see Eve here on the ground. This is our ramp here at Gateway to Space, and you can see the tow bar as well as the tug. This is how they move the vehicle around before she's actually taxiing the spaceship and taking off. So we build our vehicles here, both our Mothership Eve and our spaceship, using primarily carbon fiber. That's a composite material. It's really lightweight and really strong. So again, great performance from that perspective. And we get a lot of questions on how people fly Mothership Eve, like where do the pilots sit? How does that work? And so they actually fly in the right-hand side. So if you can see my mouse here, this is the side that they fly in. And the reason for that is because the pilot in command sits in the left seat. And so sitting in the left seat on the right-hand side gives you a pretty good view of spaceship to overview things as you're flying and carrying spaceship up to altitude. So then of course, spaceship sits in the middle underneath that launch pylon there. And then the left fuselage is actually just totally empty. And even those windows that you might see in the photo here, these are actually stickers. So it's an empty fuselage, and we typically use it for ballast. And of course, there's some open opportunities here in the future to maybe even use this as a training platform or other things. There's a lot of flexibility with having this aircraft for a two-stage launch system. So definitely some possibilities in the future, but for now, it's just an empty fuselage for ballast purposes. And it's really great having this two-stage launch system. So you can take off on the runway like a normal airplane that people you've been used to flying in their whole life. So it's really comfortable, it's really safe. And also it's really efficient, right? So we're not burning fuel all the way from the ground up. We actually have our mothership carrying us up to altitude with really efficient engines. And we're starting our launch around 50,000 feet with the rocket motor itself. So really impressive aircraft in her own right. But let's also talk about the second stage here, our Spaceship 2, known as VSS, or Virgin Spaceship Unity. So this is Unity here, and we do actually have multiple spaceships in our production line right now that we'll talk about a little bit later. But Unity is the one that we currently have here at the Gateway to Space in our hangar. And we are in the final phases of our flight test now, getting ready for commercial service to regularly be taking up customers. So you can see Unity here gliding back down to the runway. Unity, once again, as mentioned earlier, we build our vehicles out of composite material. So she's mostly made of carbon fiber as well. And one really unique feature about her is this feathering system. And our other spaceships up and coming also have this feature. And it's really unique because essentially Unity folds herself in half during flight. And what this does is it orients the vehicle such that aerodynamically it re-enters through Earth's atmosphere the same way every single time. And we call this the feathering system because it actually resembles the feather of like a badminton birdie or shuttlecock. And you'll notice when you throw those up in the air, they fall back the same way every single time with the feathers oriented up. And so it just kind of goes to prove sometimes the most disruptive designs can be the simplest and groundbreaking. So this is a really fantastic feature that allows us to, once again, like orient the vehicle the same way every single time as we're re-entering. It also keeps the vehicle really cool, and it goes in a lot slower. So it has a lot of drag that generates because of that and slows the vehicle down through that re-entry process and keeps things pretty cool. So here is a simplified technical diagram of the spaceship. So you can see the feathering system at the various stages here in this slide. And we also have some thermal protection, but as mentioned, the vehicle actually stays pretty cool. So we only have to put it in very strategic areas, of course, the leading edges, the nose, things like that. So there is some minimal TPS, but it's actually relatively lightweight and thin and not extreme, such as what you'd see on like the space shuttle, say, where they have the carbon tiles underneath. We stay cool enough to where we don't need a super intense thermal protection system, which is great. You'll also notice here that you see a lot of little spots that say thrusters. We do have a reaction control system, which is essentially just air thrusters located throughout the vehicle. And that's how we maneuver and orient the vehicle when up in space. So once you're outside of Earth's atmosphere, there's not a lot of air such that your control surfaces aren't very maneuverable from that standpoint. So we have these reaction control system thrusters in order to blow air, so equal and opposite forces. So blow the air this way and react the other direction. So that's how we orient the vehicle when we're up in space. And as you'll see from photos later, we actually orient the vehicle such that the windows face down towards Earth to maximize the view. Okay, now you'll also see this is where the door of the spaceship is located, the entry and exit. So it's the lower left side, right there in front of the very first row passenger seats, which we'll look at the cabin a little bit closer later. And you'll notice we have a lot of windows. So we actually have more windows than any other spacecraft that's ever existed. And this is once again to really just maximize that view, orient it towards Earth. Every future astronaut will have multiple windows to choose from and get that fantastic perspective, both back at the Earth and out to the cosmos. And of course, we also have our control surfaces here. So in the very back, you'll notice we have elevons, which is like the trailing edge surface of our horizontal stabilizers here. So these, of course, move in order to maneuver the vehicle. But what's interesting is our horizontal stabilizers actually all move in unison as well. Now you'll notice we have some on the inside. Here's what we call these the megastrakes. These ones don't move, but also help with control of the vehicle. And then of course you have your wings, you have your cabin, which is where, again, that main entry door, all the windows are. This is where up front here in the cockpit is where our pilots sit. And just behind them in these 3 rows here is where our future astronauts will sit. And then here you can see a diagram of our hybrid rocket motor system. So let's go ahead and get into that in a little bit further detail. So this is our CTN or case throat nozzle of our hybrid rocket motor system. Now, for those of you unfamiliar with propulsion systems, there are 3 primary kinds. Of course, there's several other kinds in various stages of development, but the 3 main types of rockets are you have liquid rocket engines, which consist of liquid fuel and liquid oxidizer. And then you have solid rocket motors, which is solid fuel and solid oxidizer. And then we have the hybrid, which is what we use. That's right in the middle. We have solid fuel and liquid oxidizer. And what this really does is actually combine the simplicity and safety of the other 2 methods. So with a liquid rocket engine, you have a lot of controllability and it's easy to turn on and off whenever you want, but it's a really complicated system in that there are a lot of extra equipment and valves and all that on board. So it's a little bit complex from that standpoint. And also it tends to be a little bit heavier as well, having all those extra systems on board versus you have the solid rocket motor, which is a pretty simple system, but once you turn it on, you can't turn it off. So what's great about our hybrid rocket motor system is we have the ability to turn it on and off whenever we want, but we don't have all the extra complicated systems that you would have with a liquid rocket engine. So it's really the perfect happy medium. That's a great safe option for flying people on a regular basis. And the one you're seeing here in the image is actually going to be on display at the Smithsonian Air and Space Museum when they open up their new exhibit here in a few years. So this is the very first space flight rocket motor that took place in December of 2018, the very first time our spaceship Unity went to space. Now this is what the cabin looks like here on the inside of Spaceship Unity. And so you can see this configuration here is meant for all passengers, and we'll see some other configurations in the following slides here. But once again, each row has multiple windows for people to look out and see not only the Earth, but also the cosmos. And it's really meant to just amplify that whole experience every step of the way. So we have window grabs around each of the windows so folks can pull themselves closer to a window, maneuver themselves around while in 0G. And also you can see some of these camera shrouds here. There's going to be a ton of cameras throughout the cabin to really capture that whole experience so people can have it to share with friends and family for a lifetime. Now, as I mentioned, it's also very configurable for other alternatives, so such as payloads. So each of those positions where we have seats, we can also trade them out for a payload rack. And what's cool is we can also have payloads and humans at the same time, as shown in this image here. So we do actually plan to have human-tended payload flights in the future. And we did actually in the past as well, our second space flight in February of 2019, we had our chief astronaut instructor on board, who we'll hear a little bit more from later, as well as some payloads. Now that wasn't human tended, there weren't any actions she had to do with the payloads, but that's certainly something we have in work in the future, where future astronauts can interact with payloads and things like that. So definitely a pretty flexible flat platform and lots of different ways we can go with this in the future.
Wow, it's unreal.
It is very surreal, very quiet.
Amazing view. Wow.
What a view. Oh my goodness, the moon off the nose.
Good grief.
View is incredible. Welcome to the club, astronauts.
I like this club.
All right, so now that we talked a little bit about our operations facility, as well as the vehicles that we have here in-house, let's talk about the flight profile and how those vehicles will go about making history and taking hundreds and eventually thousands of people to space. So this is a quick overview graphic, and we do have videos to share with you coming up here to elaborate a little bit more. But as you can see, we have our two vehicles we just talked about, our Mothership Eve and our Spaceship Unity. And they both start on the ground and take off just like a regular airplane does. So really familiar experience for people. And then also, you get up to this release phase. So our Mothership Eve is carrying Spaceship Unity up to around 50,000 feet or so, depending on the day and the mission. And then that's when you go through the release portion. So our Mothership Eve releases Spaceship Unity, and Spaceship Unity fires a rocket motor and takes off to space. Next, after the boost phase, you have apogee. Now the picture is a little bit off here. We're actually already feathered by this point. So that feather configuration you see, we actually have that feather start on the ascent. So on your way up to space, right after the rocket motor shuts down, the pilots will unlock the feather and we'll start that feather configuration. So you're kind of going up in an upside down fashion with all the windows pointed back down towards Earth. Now, once you go to the reentry phase, the vehicle, we have that reaction control system where the pilots can kind of maneuver it around. But given that whole feather system we talked about, the vehicle will actually also naturally orient itself such that it's falling belly down. So we're going to re-enter belly down through that fantastic feathering system that we already talked about and re-enter through the Earth's atmosphere. And once we get to around 50,000 feet or so, that's when they're going to defeather, and then it's going to go back into a glide configuration. So at that point, Spaceship Unity is a glider, and it's all about balancing potential and kinetic energy as she comes into land. And there's your final landing phase, which is landing on a runway, just like a normal airplane, nice and comfortable. So next, let's go ahead and look at a compilation video of an overview of this flight profile to give you some better visuals.
The first stage happens before even leaving the ground. Pre-flight is where we welcome our future astronauts and their loved ones to Spaceport America 4 days prior to their spaceflight. We'll provide all the training and preparation required to savor every second of that spaceflight. This important phase of the experience is headed up by Chief Astronaut Instructor Beth Moses, who we'll hear from shortly. Pre-flight is also the time when the ground team, who we call space wrenches, prepare both the spaceship and the mothership for flight. Some of these tasks include configuring the seats that are custom to each crew member, installing the rocket motor, providing system checks, and mating the vehicles. The next stage is takeoff and climb, where the flying vehicles begin with a gentle runway takeoff, similar to commercial airliners. This is where our mothership aircraft carries our spaceship and its crew to launch altitude, where the air is thin and to the cusp of a life-changing experience. Once the spaceflight system reaches its target altitude, Mothership Eve releases Spaceship Unity, and the hybrid rocket motor behind the cabin fires up. No sooner than you can count to 7, and the spaceship is passing through the sound barrier. Outside the large cabin windows, the sky changes from blue through indigo and finally to that iconic inky black as it leaves Earth's atmosphere. The fourth stage is the big moment, space. As the rocket motor shuts down, the cabin is transformed from a 3.5G spaceship into a one-of-a-kind spacious zone for the exploration of weightlessness and a silent viewing platform for the greatest show off Earth. The spaceship will fly above 50 miles, and the cabin has been specifically designed to offer ample space, enabling passengers to relish the freedom of microgravity helmet-free. They'll enjoy a unique experience as only Virgin Galactic can deliver. We often hear that when people travel to space, they don't come back and talk about their experience for a few weeks or months. They talk about it for the rest of their lives, and we're incredibly excited to bring that wonder and joy to so many people around the world. Once passengers have gone to where so few have gone before, it's time for re-entry. As the spaceship descends, the atmosphere around the vehicle begins to thicken, and the feeling of Earth's gravitational pull returns. The spaceship has brilliantly engineered booms that rotate, or feathers as we call it. This feathering creates a powerful air brake which slows and stabilizes the spaceship. Think of a badminton birdie that always flips its nose downward and is slowed by its feathers on descent. Of course, birdies have been around since well before the space age, so that just proves that sometimes the most disruptive designs are also the simplest. Re-entry continues with a beautiful final glide, allowing passengers to reflect on their awe-inspiring experience prior to a gentle runway landing here at Spaceport America. The final stage of flight is coming back as astronauts. Our astronauts are pioneers in the new space age, helping transform access to space for everyone. Every single Virgin Galactic astronaut will be making history. And as you can see, Virgin Galactic offers more than a trip to space. Call it an experience, an adventure, a journey, whatever name you give it, words will fall short when you return.
All right, so hopefully that really gives you guys a great understanding of what the whole flight experience is like. I do have another couple short videos here to show you what it's like prepping as well. So this video we're watching here is when the vehicles are mated on the ground. Yeah, so this mate procedure is part of our pre-flight operations that we mentioned starting on the ground. And this is one of the several things that occur in the days leading up to flight. And next, this is showing you the release portion of the flight. So once we get up to around 50,000 feet or so in altitude, our Mothership Eve will release Spaceship Unity. And pretty quickly after that, Spaceship Unity fires the rocket motor and we'll go in level flight for a couple seconds or so. And we call what we make what we call the gamma turn. So we turn, point straight upwards and head to space. And now here you can see in this video in the feathered configuration, and this is the big moment everybody waits for, is space. And if you watch here, we just showed it and we'll show it again here. It should replay in the video. You can actually see the reaction control system in work. So there you can see one of the thrusters firing as well, just to give you an idea of how they control the vehicle in space. And then here's the glide portion of the flight. So you can see the runway off to the left there as Spaceship Unity comes back in to land here at Spaceport America. And just to the right there, you can see kind of in the screen our chase aircraft. So the chase aircraft is an integral part in our flight test system. It just gives you an extra set of eyes on Unity and also gives us fantastic aerial footage to be able to share with everyone. We can also talk a little bit about Spaceship's landing gear here. So you can see the main gear in the back, those are wheels, but the front nose landing gear is actually a skid. And the reason being, it's actually a really lightweight and simple system to have. In Spaceship, Unity never needs to be able to taxi around on her own. She's always attached to Mothership Eve prior to takeoff. So to come into land, all we need is that nose skid. And then we do have a partnership with Range Rover. And so we actually tow our Spaceship Unity back to the gateway to space using our Range Rover fleet. All right, so now that we've talked about our gateway to space, as well as the vehicles we house here, let's talk about the people that are going to fly aboard these vehicles, starting with our world-class pilot corps. So these are just a few of the pilots that we have shown here, and our team is growing. And they're getting really excited here to start regularly taking people to space. We have a fantastic pilot corps that just comes with a wealth of experience and all sorts of flying machines that they've done throughout their career. Just really impressive, extensive career and history there. And you can see they're sporting our new spacesuits. And these were designed in conjunction with our partner, Under Armour. And you'll notice they're not your typical spacesuit. So we are not going to be having a super harsh environment on our ride to space. So it's not as intense as what you'd see with NASA astronaut spacesuits, because our cabin is actually pressurized. So it'll be very similar to riding in an airplane. Now that said, these suits are still specially designed to be able to amplify the experience for both our pilots and our customers. So they do help regulate temperature. They're very comfortable and very flexible, making it easy to move around when in that zero-G environment. So our future astronaut spacesuits are similar, but they do look a little bit different, and they're very customizable. So everybody will have their own with their own custom name, and they also can have their own space mission inside attached to that. And they also have several pockets on them so that folks can carry aboard things that are really meaningful to them, such as photos or jewelry or things like that that they want to bring to space with them. Now, our future astronaut community is very extensive. We have around 600 people that have signed up to go so far. And that is actually more than have ever been to space in the history of the world. So we have less than 600 people that have ever been to space, despite the fact that millions and millions of people are interested in going. And so we're hoping to change that here at Virgin Galactic. we want to open space for everybody. And our whole goal is to be a space line for Earth. And we've got a really good starting point here with our future astronaut community. We have folks signed up to go with us in over 50 countries right now. And over half of those have never actually seen a space flight before. So they'll be the first from their country to go to space. And more than a dozen of those have been to space, but haven't seen a female astronaut go to space yet. So a lot of really exciting firsts will be happening with our future astronauts. Every single one of these flights is going to be historic in one way or another. And it's just really exciting to start that foundation of just opening space for the whole world.
I'm the chief astronaut instructor and
now with that, let's go ahead and hear from one of our astronauts that has gone to space with us so far, our chief astronaut instructor, Beth Moses.
The chief astronaut instructor and a flown astronaut at Virgin Galactic. I was the first person to fly in the customer cabin of Spaceship Two as an engineer and an instructor testing the cabin. And that flight showed that the cabin was ready for human occupancy. I flew in a prototype cabin with research payloads, tested a lot of things. It tested a few ways to get in and out of the seat. It tested ways to improve the seat interfaces. It tested translation aids, handling aids, how you move about the cabin. Very fundamentally, it looked at how the cabin moves about you when you are floating and weightless. What aspects of the experience stand out, perhaps in ways that we didn't anticipate before a human could go calibrate that. So now I've rolled that all into training and into the cabin design so that it is perfectly tuned, elegant, easy, safe, wonderful. It was already freaking remarkable, and now it's even more so for all of our future customers. So the moment where we strapped in and the hatch was closed and the wheels started to roll sticks with me as a moment of sort of personal gravitas, like I am about to do the most important job of my life and I am going to do it well. The rocket motor is not exceptionally loud. You are under 3G, you are rocketing into space. It is the rocket ride of your life. And then the rocket motor cut off. You can see the Earth outside all the windows. It is super, super bright, very high definition. It just engulfed me. Space is deep, deep, deep black, and it looks endless. And probably the next standout moment, I did the first half of my test, and then I purposely joined the pilots near the cockpit for apogee. And that's probably the standout moment of my life. Floating, free, in the ship, and the ship came to a stop above Earth, and it felt endless. The cabin interior supports savoring the view of Earth from space in every way possible. It both facilitates your movement about the cabin, so you can get to any window or next to any person that you'd like to, while simultaneously not distracting you from the view that you're looking at. The cabin interior will be successful when the space flight and the view of Earth from space is the star of the show, and the cabin is almost an invisible but perfect supporting act.
It's always so awesome hearing Beth speak, and I'm so excited for hundreds and then eventually thousands of astronauts to go through and have that experience as well and hear what they have to say about it. They talk about the overview effect, which is essentially a transformative experience that astronauts go through for the first time when they go up to space and see Earth from above. And I think having that experience across so many people in the world is really going to benefit the world in nothing but a positive way. And I'm so excited for so many people to experience that. It's going to be great. So let's go ahead and back up and talk about manufacturing now. So our manufacturing takes place in Mojave, California. This is where the designing, the building, the ground testing, and the initial flight testing of our vehicles take place. So there are a couple different buildings we have at the Mojave Air and Spaceport, but the main one is FAITH. FAITH is actually an acronym. It stands for Final Assembly and Integration Test Hangar. Quite the mouthful. I think they just came up with the acronym and then tried to make all the words match, but it's a fantastic name for everything that said. So here you can actually see a lot going on our FAITH shop floor. This was back when we had our mothership Eve and our spaceship Unity. You can see in the very back of the photo there in initial flight test phase out there in Mojave. And then you can see it kind of closer to the front of the photo here. We have our next two spaceships in our production line, and we'll talk a little bit more about those next. But you can see a lot going on the floor here. We have all of our individual components laid up, as we call for making composite parts, in different facilities. And this is where they all come together for that assembly phase. And then also, again, the main hangar for operations of flight test. So you can see here, this is where a couple of different parts for our vehicle are being assembled or put together. And you can see they've got a jigging fixture around them. We do a lot of composite bonding here at the facilities. And that's essentially super glue for composites, really strong adhesive to adhere multiple components together. This is also where we do some major curing operations. So you can see this is a boom structure. So that's where that feathering comes from here. So we've got our torque tube in the middle, and we've got these two booms on either side. You can see on the left boom here, we have Celotex. So this is actually an in-house oven made to help cure our adhesives. So these adhesives cure under temperature. And so we have to be able to elevate that and build these specific ovens around these complex shaped parts. So that photo that I just showed you is an old photo of the boom assembly of our new spaceship, VSS, again, Virgin Spaceship, Imagine. And so this is what Imagine looks like now. You may have seen in the news recently, we did have the rollout of our spaceship Imagine. And the next right behind her, as you saw in that original photo, will be VSS Inspire. Let's go ahead and take a look at the unveiling video for VSS Imagine.
We were born to look up. It's intrinsic, instinctive, undeniable. To be human is to be curious. To wonder what lies above. To dream of what awaits. To imagine what it feels like. What it sounds like. And what it looks like. Virgin Galactic.
Welcome to space.
Imagine will take you there. Introducing VSS Imagine. The first Spaceship 3 in the Virgin Galactic fleet.
All right, folks, well, that's all I have for you today, but thanks so much for joining us on the virtual tour.